Okay, this will be my third YouTube video, and this time I'm going to talk about a video produced by a Josh Fernstein. Not sure if I pronounced his name right. I don't currently have anything that I could use to share the video with you while I'm going over it, but I will have it playing in the background so we'll be able to hear what he's saying, which is the more important thing. Throughout the most of the video, he is basically ranting in what appears to be a car while someone else is driving, I'm assuming. He does have a backwards red ball cap on, so he kind of looks like Fred Durst in that way. Um, but he starts it off talking about that an atheist had called him stupid, and he wanted to respond to that. Now, I don't personally plan on, the atheist was calling him stupid for believing in creation, um, according to the Bible. Now, I'm not personally going to call him stupid for that, but I did catch several other things that weren't all that bright. So I'll leave a link in the comments section so that everybody can actually watch the video on their own and come to your own decisions on this. But here's my impressions on him.
As Josh Feuerstein here, the other day I had an atheist tell me that I was an idiot, moronic, and stupid for believing in God, that he created this world, because it took way too much faith to believe in a process like that, while he believed in what he called the science of evolution. Well, let's go ahead and let's do this. Dear Mr. Atheist, first of all, let me correct you, because evolution is not a science, never has, and never will be. Why? Because it cannot fit within the parameters and parentheses of science for one simple reason. It was never observed.
Okay, so let's start with a couple things here. Evolution is a science, and it's taught by most science teachers and in practically every college you go to. There are actually these nice little people who walk around and do great experiments and great discoveries who are called evolutionary scientists. It, in fact, is a science. Now, the second part to this, he says that it doesn't fit into the parameters of science because it was never observed. He's making a couple of basic errors here. First of all, there's a lot of science out there that we have never directly observed. For example, up until recently, black holes were a bit of science that was it was indicated in Einstein's theory of relativity. The fact that gravity could curve to the point where even light could not escape. So it's not something you can directly observe. You have to look at other effects to actually see that a black hole is there. More specifically, as a black hole crosses across or moves in front of a star, you'll see the star move. The second thing about this that we haven't directly observed is dark matter. We can't see it. We don't know what exactly it is. But in the same way that we can see light bending around a black hole, we see the effects of dark matter because we see other objects curving around them. And again, this is something that's not observed technically, but scientists still believe in it. Now, the other problem with this statement is we actually have seen evolution happen. A good example of this is E. coli bacteria. Now, the E. coli that's in your stomach doesn't live well in citrate. Now, after 30 generations or so, in the lab they found that you can actually develop E. coli, or that the E. coli will develop naturally to be able to live in citrate. Um, Other things that we see that, that are examples of evolution is within, I think it's around 100 years, we've seen certain species of fish who become trapped in caves and such, where there's not a great deal of light. We see that the eyes start de-evolving, or they start losing the ability to see at birth. So we have seen it in that statement as well. We also can see certain parts of evolution in animal breeding or animal husbandry, as well as doing the same thing with plants. And this is to say what with natural selection, with evolution, you have processes in nature which make certain traits more valuable. In other words, certain traits will allow you a slight advantage in surviving. And since you have a slight advantage in surviving, you can reproduce more, which in turn means that that trait carries on in the species. And it's the small building up of individual traits that actually creates evolution over time. Um, with animal husbandry, what we see is the best example I have is a cat breed. I believe it's called the Cornish Rex. One of the traits of this cat breed is that the ears are folded over on themselves. Folded, well, not like this, but back on themselves. And what this is that there's a specific gene or trait that causes a cartilage deficiency. And it causes the ears to twist in that way. It also causes the whiskers to twist oddly. Now, a breeder had one particular kitten that had this trait, and this breeder decided that they liked this trait or liked the way this cat looked, and selectively bred that cat or selectively bred that trait. Now, it's not evolution in the sense that it's not nature necessarily causing this change to happen. It's our actions, but really it's the same thing. It's actual evolution in action that we're causing. So we have observed evolution in that case as well. Another example of evolution that we've noticed is what's so-called junk DNA. Now, somewhere around 90% of your DNA code, my DNA code, and every other human's DNA code is genetics that create traits that we no longer exhibit. For example, genetics for a tail. We technically have a tail, but it's really, really small and fused together. So it's not what we would typically call a tail, like what a cat would have or a monkey would have, so on and so forth. Um, we also see things like in the genetics in birds. We see the genetic code for teeth, something that birds don't have anymore. Um, so it's presumed that these are traits that are left over from previous species, from progenitor species. Um, with tails, in our case, it would be from the primates. With birds, we believe that birds evolved from certain types of dinosaurs. We can also see other traits that are left over or kind of throwbacks. For example, in the whale. Now, with the well, since it swims in the ocean, it kind of looks like a fish, right? Um, but what we notice in the skeletal structure of practically every fish that's out there is there aren't any hips. Now, this kind of makes sense because if you're in the water, you don't have to have that additional structure to lift you off the ground or to combat gravity. Whereas all land species, outside of things like snakes and technically insects, um, have hips. Whales also have hips. Now, our current theory is that things like whales and porpoises lived in on land at one point and then went back into the water. And the hips that are in whales, they're incredibly small and they're going away, but they're still there. They're a throwback to a progenitor species. So we see evolution in that way as well. So, I mean, we do see lots of evidence that evolution exists. So let's see what his next point is.
That's why it's not science. That's why it's called the theory of evolution. One man's theory. Now, let me show you how much faith it really takes to believe in evolution. You want me to believe that in some accidental cosmic bank, that out of that was created one cell, and from that one cell that all life springs, every plant, every animal, every single human being, and that somewhere along the way over years and years we mysteriously and magically all develop different wills, and we all develop different characteristics and traits, all because we willed it in our... I mean, you really think that everything came from one single cell? How much faith does that take? Now, I realize that you say that evolution is in science, and yet if we go back...
All right, let's actually jump to one of his points there. He says that it takes a lot of faith to believe that everything came from one cell. Not really, because if you think about it, we all started as one cell. Sexual reproduction all starts with two kind of half cells. An egg doesn't have a full nucleus. It doesn't have all the genetic information. It's not to say that the DNA code's chopped up in there. It's just that the individual chromosomes are broken in half. So it doesn't have what it needs to create to function really as a cell. Now, the same thing is with sperm. It's not complete technically to be a cell. Now, when these two meet and we have the chromosomes, I think I actually said that wrong. When we have the chromosomes mixing or getting together, then you have a complete cell. And that one complete cell is what we really all started as. One little egg and a woman. Now, a flip side of that is you have the same thing with plants. Plants that sexually reproduce, that is. They produce pollen, and that gets together with the flowers, I believe it is, the pistils in the flowers. And again, it produces one egg, the seed, which then can grow up to be a plant. Now, asexual reproduction, well, most asexual reproduction is in single-celled organisms. So again, one cell, that becomes a full organism. Certain species can do asexual reproduction, but still, again, you're going back to the point that it all starts with one cell. So there's not really a whole lot of belief that you would need to understand that or to believe in that, because it's not necessarily amazing that all life came from one individual cell because, well, all life does come from one individual cell, just an egg cell. So, continuing on with his argument.
To science, the one thing that science demands, if you maybe you've heard of something called the law of thermodynamics, which means that chaos can never produce order. Look at the world that we live in. The sun goes up, the moon comes out, we travel around the sun, we have years, we have days, we have seasons, the tide comes in and out, everything works like a clock. It has order. And yet, you cannot argue that a world that has order came out of an accident because it defies the very logic and laws of science.
Okay. This is a misinterpretation or a misquoting of the second law of thermodynamics. Now let's give you a little bit of a thought, a little bit of backstory on thermodynamics. Thermodynamics deals primarily with the exchange of heat. Now the second law of thermodynamics, also known as the law of entropy, says that in a closed system, things will naturally progress from a state of order to a state of disorder. And it's a really solidly held belief within science, or solidly held law within science. Now, the big problem, or the kind of bait and switch that he's doing here, is when you look at the Earth is not a closed system. Let me give you an idea on this. A closed system essentially means there's no matter going into the system and no matter leaving the system. There's also no energy going into the system and no energy going out of the system. That's what a closed system would mean. The problem with this, especially when you deal with the Earth, is that there's literally tons of matter that fall to the Earth on a yearly basis. We pick up asteroids, well, meteorites, from Antarctica all the time. And there are actually people that make a good living walking around in various places picking up meteorites and selling these to science facilities, museums, things like that. The second thing is we get quite a lot of energy from the sun. So we're not a closed system. To give you kind of a thought experiment on this, imagine you have a table, and on this table you take M&Ms and you separate all the M&Ms out based off of color. You have each little color in its own specific pile, and then you attach a engine to the bottom of it that just shakes the table. Now the engine shaking the table kind of represents time. So when you turn that engine on, it shakes the table, and as time progresses, what happens? Of course, the piles are going to fall apart, and if you leave it there enough, or leave the engine on enough, it's going to spread all the colors out and mix them all together in a very chaotic manner. So instead of having these orderly piles like we started with, over time, these piles become a mess. Okay, so if we set it back up like we originally had it, and this time we have people who are holding funnels above each pile and adding in the color for that pile. When we turn the engine on again, they're adding the M&Ms onto the table, and then what do we end up with? Well, of course, we end up with a lot of a really messy table as far as the piles will continue to fall apart, but since we're adding more into each individual pile, we still have that bit of order, those piles. It's just we have those piles and we have a whole mess of chaotic mixture of M&Ms. Now, if we reset it a third time, and this time, instead of having the people dropping more M&Ms onto the table, we have them sit there and hold the piles together, and we turn the engine on. Then what do we have? Well, assuming that our assistants are competent and able to um, actually follow instructions, we'll still end up with ordered piles. Now, stepping back through our experiment here, our first experiment is the control. Over time, the piles disappeared. And instead of having order, we had a chaos or a mixture of M&Ms of all different colors mixing together. In our second experiment, where we constantly add matter, the M&Ms, we still had the mixture of M&Ms all over the place, but we still had a semblance of order because we still had those individual piles. This would be like if you're adding mass into a system. The third option, or the third test, is instead of adding matter into the system, we're adding energy into the system. The effort it took to actually hold the piles together. Excuse me. And we ended up with orderly piles again. So this is what he's missing with his comment about the second law of thermodynamics, is that the Earth is not a closed system. In fact, quite a lot of energy and quite a lot of matter is being put into the Earth, and that is how the Earth can develop more and more complex systems. Even beyond the sun, we've also found that in the deepest oceans, much more than a mile down under the ocean, you don't get any sunlight. So it was originally thought that below a mile there was no life. We found that's not quite the case, though. Even on the ocean floor in deep ocean, there's life there. It's not based off of sunlight. It's based off of sulfur, chemical energy, which is coming up through the surface of the Earth. So again, we're adding energy to the system. The second law of thermodynamics does not disprove evolution because it doesn't have an effect on a system that's not closed. Now, if we pull back and we look at the universe as a whole, the universe as a whole is still falling apart. So even though small pockets like the Earth are becoming more and more complex or more ordered, the universe as a whole is becoming more and more disordered. In fact, for the most part, all the galaxies that we see are receding away from us. One or two are coming towards us, and one or two are moving in a neutral direction to us. But in a large part, the galaxies are getting farther and farther apart, which is kind of leading scientists to believe that instead of having a big crunch or instead of having the universe explode, that the universe is kind of going to go out on a whimper, that it's just going to get farther and farther apart from itself, and everything's going to get darker and darker. The stars are going to die, and eventually it's just going to be black. Kind of a sobering thought, but they don't expect that to happen for another 13, 14 billion years, so not anything any of us need to worry about. And let's continue on with Josh here.
You see, you think it takes a lot of faith for me to believe in a God that created this world, a God that created order, and yet, what if I were to tell you that somewhere in Oklahoma, a tornado rolls through a junkyard full of a bunch of old cars, and somewhere on the other side of that tornado, out of that junk pile, it magically produces a perfectly red, shiny, working Lamborghini. You would tell me I was nuts. You would tell me that I had lost it. You would probably try to admit me into the psychiatric ward. Why? Because that is absolutely stupid. I mean, how much faith would it really take to believe something as idiotic as that? And yet that's exactly what science believes. Science.
Okay, so here again, he's using an argument that has two flaws to it. Now, the first flaw is, yeah, for life to end up on the Earth, there's a really, really small chance for that to happen. But let's step back and take a look at a couple of things here. In our solar system, just our solar system, there's Venus, Mars, Io, and Ganymede, I think it is. There's a couple others that I haven't mentioned that I've kind of lost track of the names and such. But these are all places where we have evidence that liquid water was at one point. We have evidence that it has organic chemicals or the precursors for organic chemicals. And that's mainly carbon containing chemicals, and that have the right chemical composition and size to have created life. Now, Venus, it underwent a uncontrolled greenhouse effect. So right now, it's not likely that we're going to find life on there. To give you an idea, the average temperature is somewhere near 650 degrees. Lead is molten at that point, so not very likely that we're going to find life there. Mars, it's possible we might find life, but Mars has lost its atmosphere, so it's not very likely that we're going to find life there. But we do know it has liquid water, or not liquid water, but it has frozen water, and it has all the chemicals necessary for an atmosphere. It's just it doesn't have one right now. And what little atmosphere it does build, since the core of Mars went cold, it's geologically dead, in other words, as far as we're aware. There's no magnetosphere, which means charged particles from the sun hit it and pretty much knock off any atmosphere that does show up on Mars. So it practically doesn't have one. Ganymede and Io, they're moons around some of the gas giants. Now, the amazing thing that we found on these is that they're primarily water. Now, they're far enough away from the sun where the water freezes on the surface of them. But what happens is, due to tidal influences, in other words, in their orbit around the gas giant, they get squished and pop back to their original size, depending on which part of the orbit they're in. And due to this, that creates a lot of friction, which creates the possibility of liquid water under the surface. And with that possibility, there's the possibility of life. Now, that's like 4 planets, 5 planets if you throw in the Earth, or planetoids in our very solar system that could support life. Now, when we look out at the night sky, especially through telescopes, we can see somewhere around 300 billion stars in our galaxy. In fact, if you look up at the night sky, you'll see there's one part of the night sky, one band, that's kind of a lighter bluish color compared to the black backdrop of most of what we see in the night sky. That's the Milky Way. That's our galaxy that we're in. Now, It's lightish blue because it has stars, lots and lots of stars. And like I said, we estimate somewhere around 300 billion stars. Beyond that, when you look at the black parts of the sky, you'll also see little stars in there too. It turns out some of those stars aren't actually stars; they're galaxies. They're just so far away from us that we don't really see them as galaxies. We see them as individual points of light. And when we look through our telescopes, we see that there's some 3 to 600 billion galaxies out there. Now, our galaxy, the Milky Way, is by no means the largest galaxy out there. In fact, here in about 4 billion years or so, 4 to 6 billion years, I'm not sure the exact time, Andromeda, which is a much larger galaxy, is set to collide with us. But that's beside the point. Now, we've also noticed with the Kepler telescope that most stars out there do have planetary systems around them. And a lot of them are larger than our solar system. Now, if there's 4 or 5 planetary objects in our solar system that can support life or could have supported life at one point in time, and we assume that that's similar to other solar systems, you're dealing with large numbers. And even though the possibility that life can exist on any individual planet is small, you're dealing with a lot of planets that are out there. So I'm more along the lines that I would be surprised that there's not life out there and lots of it. That would surprise me more than that Earth has life on it. It's just the numbers. There's way too many planets out there for us to assume that life is only here. And it also makes it the whole argument that life developing on its own is so insignificantly small of a chance. Not really. Not with the number of stars and planets that are probably out there. Now, the second thing about this is really, according to evolution, um, first of all, evolution doesn't really deal with biogenesis or the beginning of life. It just deals with what happens after life begins. It doesn't describe how life started on Earth. It describes what happens once life takes hold. And it describes how there's so much or so varied species here on Earth. Um, the reason we have species that look like butterflies and species that look like people and species that look like little mounds of dirt. That's what it describes. But beyond that point, if um, without a God, it's not a chance that life began. It's causality. It's these chemicals on this planet with these certain conditions will combine in this way. And then since they've combined in this way, they'll start evolving. Um, I guess, if you look at life as it is right now, 2 people meet, a male and a female. They get together, they have sex. They have sex at the right time. It's not a miracle that they get pregnant. It's an inevitability that they get pregnant. Or if they have sex enough times, it's not a probability that they get pregnant, assuming both are healthy. It's an inevitability that they get pregnant. Not chance, causality. So that argument's a little bit dumb.
Science believes that in this accident came this perfectly working earth with human life and with people and animals and plants and
The world hasn't worked perfectly ever. There are always things that are causing disaster. There are always things that just don't quite work right. Um, Beyond that, I mean, if you look at just look at the Earth-Moon system, we are losing the moon. It's only like a couple feet per every 100 years or so. That's not a very fast progression, but it's happening. So that doesn't really tell me that this is working perfectly. Um, and beyond that, you've got, if we look back in history, mainly using ice cores, um, also rock cores, they can get some ideas from them. But the atmosphere at one point was so toxic it would have killed us. Um, the Trying to think of the name of it. Um, I think it was Precambrian era. There weren't any plants. No plants, no oxygen. So the air was pretty much didn't have the oxygen content required for human life. All life was in the ocean at this point. Um, there was another point, I think it's called the Coniferous era, where there were plants everywhere. And the problem with plants being everywhere at this point, well, first of all, you had arachnids, spiders, that were the size of small dogs. You had centipedes that were 6 foot long. So you had giant insects, which would really freak some people out. Of course, I'd probably be freaked out if I saw a dog-sized spider coming after me. Um, but beyond that, the oxygen content was much higher. That's probably the reason that they had large insects at that time. And the problem with a high oxygen content is, well, fire. Forest fires were a lot more devastating at that point because you had a lot more oxygen to fuel the fire. Um, and those are just 2 points in the history of this planet where things weren't perfect for us, and that's not counting the Yosemite supervolcano exploding. There's about 6 other supervolcanoes around the world that have also exploded, and these are events that could wipe us out pretty quickly. Now, it may not. I don't necessarily agree with the worst of the doomsday people as far as that goes, but if it doesn't kill us, it will knock us down to a very, very small population. It will pretty much kill modern technology. It'll kill most of the modern conveniences that we have. We'd end up living like primitives for hundreds of years afterwards, most likely. Um, Beyond that, you've also got other events that have caused worldwide devastation. Plagues, you've got asteroid strikes, um, well, asteroid and meteor strikes that have, meteor strikes really, that have caused worldwide devastation. And this is not a sign of a perfect world, at least not in my opinion. Let's see his next argument.
seasons and days and hours and rotates. I mean, the atmosphere, everything in Earth was created perfectly. And I'm telling you, that could never happen through an accident. It had to be by intelligent design. So,
Okay, so again, like I said, the world's not perfect. Second, the reason that it appears that the world is designed um, is actually because of evolution, and that is, I think Thunderfoot was the first person that I heard mention this. He's a YouTuber that I suggest you go check out at some point. He's pretty entertaining and informative. But his constant comment is that evolution is plastic to the environment. Now, what that's to say is that the way evolution works is that designs, traits that do not fit with the environment don't last. They get weeded out of the population pretty quickly. Um, this can be this is one of the reasons that we say that Neanderthals disappeared, and that is that they could not evolve, or their traits were not changing fast enough to keep up with the environment that they were living in. And a lot of animals that have became extinct suffered from the same thing. That is that the traits that they needed to survive weren't showing up fast enough in their population for them to survive. Um, a good example of this, again, going back a bit to the whale. We know at one point it was a land animal, but for some change in the environment, the whale started spending more and more time in the water. And as it spent more and more time in the water, it developed traits like its flippers, like its fins. Its tail started changing shape. And through small trait changes, it became the majestic creature that it is today. Not created by intelligence, causality. The fact that it moved into a new environment and the traits that it needed for that environment were selected over the traits that it didn't need for that environment. And in this way, it became engineered for where it's living now. So the world looks like it was created by an intelligent designer, but this is not necessarily the case. It's just that things evolve to fit their environment.
Dear Mr. Atheist, who really has to have a lot of faith today to believe in their theory? I believe in God because I've experienced Him, I've felt Him, but most of all, while driving through Yellowstone and Montana and so many of these natural reserves this week and looking at animals and looking at life, I don't know. I just can't look at all of that creation and say that it was an accident. I have to say that creation has a creator. And one final thought. Well, the word universe, you believe in a big bang, but when I look at the word universe, it means una, which is one or singular. That's Latin, universe. Verse means a spoken statement. So universe is one single spoken statement. I dare you to read Genesis 1. And in the beginning, God said, let there be. All God had to do was speak one single spoken statement and boom, the universe. God bless. I dare you, if you believe in God, if you believe that all of this stuff is nonsense and you have enough faith to stand up and say, I still believe in creationism, I still believe in a God that reigns above all, then I ask you to take a moment and click share. Click share below.
Okay, so his last statement, universe meaning one spoken word. No. Yeah, he's right on that. It means one. Unicycle, one will. Um, verse means all. So literally, universe is translated as all combined in one. Now, it's kind of a misnomer in that science is currently thinking that there may be multiple universes or a multiverse, which would technically mean not everything is contained in our universe, but that's kind of splitting hairs. The universe literally says all, everything in the universe contained in itself, in the universe. Um, Not one spoken word. Now, I'm of the personal opinion that you don't need to abandon any form of faith as far as religion goes to believe in science, but you can't go in and deny something that's withstood the test of time, like evolution, with very, very weak arguments. So, really, I don't want to call this guy stupid because of his belief in God or in the Bible. Uh, Personally, I like to consider myself a agnostic theist, meaning I believe in God. I'm just not all that sure which God is God, or if any of the religions really have the whole "who is God" nailed down. So I'm not going to question his faith in the Judeo-Christian um, ideology. What I am going to call him stupid for is none of his arguments really do what he wants them to do. And as an added note, he used the argument of the second law of thermodynamics, but never touches that his creation theory would not be counter to the second law of thermodynamics as well. So just as much as he could have used it to threaten evolution, which really he couldn't, it could be used to threaten his religion. And more so with his religion because the creation in Genesis mentions the creation of the entire universe, which is bringing order out of chaos. Whereas the theory of evolution just deals with Earth. But that's that's just a matter of your faith. Um, I don't have a problem with it as long as you don't deny proven or well tested science. So I'll leave it with Mary Meeting. If you like or agree with this video, please like and share. Thank you, and have a good day.